Okay, so after the practice questions from the last couple of days, we have a whole bunch of little what would be called redox tables showing us the strongest oxidizing agent going down to the weakest, the strongest reducing agent going up to the weakest. And we could use these to figure out if other reactions were spontaneous or not. So we have this whole set. We also have these ones. Now, wouldn't it be nice if we could take all these individual tables and put them together to create one big one that we could use anytime we wanted to figure out if a reaction was spontaneous? Well, it's a brilliant idea, and I hate to tell you, but someone thought of it before you. Okay, so today you will be getting this chart. I couldn't give you this chart beforehand. It would have made all the other questions too easy. And if we were in class doing a test and an exam at the end of this, you would only get this chart you get it at the very beginning of the test, the very beginning of the exam, with directions to do particular questions. And once you were done those particular questions, I would take the chart away and then give you ones where you had to create charts. Because really creating a chart, when you have a chart, takes all the fun out of it. All right, so if you look on this chart, though, you will see some of our nice, easy half reactions that we've been using, but then some more complicated ones that we haven't seen yet. Okay, and what we're going to move into, we'll be using all of these. Notice that some of the compounds, some of the ions show up more than once. One of those some is H positive, right? H positive is here, it's here, it's here. So, but, and then of course it is also by itself. Okay, so when we're using the chart and looking for particular entities, you have to check the whole chart on both sides because it's possible that things will show up more than once. So one of the things, or actually what I'm going to get you to do this evening, is to get used to the chart. There's a question sheet called Questions Using Redox Half Reaction Table. And it will ask you to find things on the chart and just to get used to using it and looking for it, okay? So now we can use this chart to figure out if a reaction is going to be spontaneous or not. So if it's a reaction between Cl2 gas and silver, the Cl2 is the oxidizing agent, the silver metal is the reducing agent, oxidizing is above reducing, it would be spontaneous. But if it's a reaction between gold solid, which is up here, and maybe lead down here, this time the oxidizing agent is below the reducing agent, and this one would be non-spontaneous. Okay, so our chart is going to come in very handy as we predict redox reactions, and that's what we're going to move to. So there are some steps that we will use in predicting redox reactions. So what's going to happen now is you're going to be told that, like, what are the entities present, and then you have to figure out, okay, are these entities oxidizing agents or reducing agents? Find the strongest oxidizing agent, find the strongest reducing agent, check the chart to see if one is above which one's above which to figure out if it's spontaneous or not. So as we move into this, it's important to realize that the majority of atoms and molecules and ions are stable and don't readily release electrons. The ions, like once they have them, once they're in their stable ion state, they're happy. So the two entities involved in a reaction are really in a tug-of-war for the electrons. And the one with the stronger attraction is going to win. And that goes back to, if we're talking elements, it goes back to their electronegativity. Okay, so the steps in predicting a redox reaction are list all the entities present. Then, using the table, find them and see, are they on the oxidizing agent side or the reducing agent side or both? Okay, and then you mark that down, and we'll do an example here to show you. Okay, then you choose the strongest of all the oxidizing agents. Maybe we should just do this. Okay, so example 1. No, I can't do it. Okay, let me finish because I want to do the things to remember. Okay, so you write them all down. You use the table to figure out, are they oxidizing, reducing, or both? And some of them will be combinations, and I'll show you how to indicate the combinations in a minute. Then you choose the strongest oxidizing agent and use that as the oxidizing half reaction. And you just write it right off the table. It gives you the half reaction. Then you choose the strongest reducing agent and you write its half reaction right off the table down. But remember, for the reducing agent, you'll start from this side and write this way. So if I don't know, if nickel is your reducing agent, you would write on your paper Ni solid going to, right? So you would go this way across the sign. I'll show you in a minute. Then you balance, of course, the electrons, and then you add the two equations together and write the overall net equation. And then you go back and you predict whether or not it's spontaneous by going back to your strongest, back to your weakest, and seeing which one's higher. Back to your strongest oxidizing agent, back to your strongest reducing agent, and see which one is higher. So before we do the example, I just wanted to remind you of a few things. When you see the word aqueous, it means one of the entities present is water. Okay? When you see the word acidic, it means one of the entities present is H positive ions. If you see the word basic, it means there are OH ions, -1 ions there. Remember that some OAs and RAs are combinations that you'll see, and you can only use them as an OA or RA if everything in the half reaction on the reactant side is present. Okay? Some molecules can act as both, okay? And so we'll discover that too. I don't want to talk too much about that because that'll ruin your homework. All right, so the first example is copper metal is placed into an acidic potassium permanganate solution, okay? And I'm not going to give you any of these tonight. We'll come back and work on these again tomorrow, okay? Tonight we'll just be getting used to the table. So example 1, it says a copper metal, so Cu solid, is placed in an acidic, H positive, potassium, K positive, because remember they'll dissociate, permanganate, MnO4 negative, solution, H2 liquid. Okay, so you write all your entities down. Now you go to your chart and you look for copper. And when you look for copper, I'm looking, copper solid, you should find it on the reducing agent side at about positive 0.34. Now it doesn't matter the number, I'm just telling you where it is, so as you're looking for it you can find it. So it's a reducing agent. So to keep your life simple, mark your RAs underneath, okay, and your OAs on top so that they're not all mumble jumbled together. If you look for your H positive ions, you'll find it on the oxidizing side at negative 0.31 OA. And it's there with a whole bunch of other things. We'll only worry about that when we get to the other things. If you look for your K positive, you will find it on the oxidizing side, second from the bottom, OA. If you look for your MnO4, you'll find it very close to the top, third from the top, but it's linked to your H. So if you didn't have H positive ions here, you wouldn't be able to use this. But because you do, you would go like this and you would write OA on it because it's an oxidizing. And then if you look for water, you will find it on both the OA side and the RA side. One is at negative 0.83 and the other is up at positive 1.23. Okay, so you've listed all your entities. That was step 2. Step 3 was figure out which one's the strongest. Well, this link is the strongest oxidizing agent. How do I know? It's third from the top on the oxidizing side. And I only have 2 reducing agents, copper and water. And copper is lower. The water that's the reducing agent is up at positive 1.23.